Let's see. Okay, it's going now. All right. So I think we're up. And, hopefully the guys will just get back to saying that everything goes fine. Yeah. McLean, thanks very much for the time that you joined us. A few words at the very beginning. We line online talks at CryptoBazar Talks. Basically, behind that is to discuss different how innovative ideas are being implemented in the area with the. So thanks.
Absolutely, yeah. Thanks for having us.
Cool. Yeah, the first question here is, I mean, it's quite an obvious question, probably. The question about the name of the company, NuCypher. Some people I heard call you NuCypher, which is, you know, resembling one of the guys from a very well-known book, let's say. Any assimilations with this, or how do you come with a name like that?
Yeah, so no relation to Lucifer. So it's NuCypher. Basically, a cipher is a secret code, and there are a couple different ways to spell it, with an I or with a Y. And then we just kind of appended new on there to kind of indicate that it's like I guess a new or a more modern way of doing encryption.
Which is, I mean, okay, that thing would be okay to run with the third-party server and independent server that you would need to definitely trust, right? And but that thing, of course, is very, let's say, not very trustworthy, maybe, or I mean, it may have pretty much three drawbacks, right? I mean, in terms of your access to sensible info, right, which can be leaked to to the community. The second thing, of course, is the let's say high load problems when everybody, all the servers would come up to one point to actually to access the data. And of course, the third thing is the low failure of the one node, that everybody's accessing. So you have the other technology, which is PKey, EKE, the key encryption, where you have the peer-to-peer, which, from what I understand, of scalability to talk peer-to-peer. Now, how do you solve it as your approach?
Sure. So, at the beginning, you mentioned like HTTPS or TLS, and in a way, that's kind of what you're using, and the web server that you're talking to is secured using HTTPS, and that means it's all the traffic between you and the web server is encrypted in transit, which that makes sense, right? Like, I mean, frequently you're sending data over there to be processed, and they by definition need to have access to that plain text data. And I mean, in many cases, like, it's generally people trust Dropbox, Google, and I mean, some people don't, but as a society or culture, for the most part, we've kind of accepted that. But when you kind of extend that to this new world of decentralized applications, having just encryption in transit and decryption into plain text server side is basically a complete non-starter, because in this side could be like an IPFS node that's sitting in some guy's basement, or in a jurisdiction like with an oppressive regime or something like that. Basically, it's not feasible to trust whoever's running that node. So there has to be some additional end-to-end encryption layer where you're not just encrypting in transit, but you're encrypting the entire time. So from the point where the data leaves your control or your device client side, from the data owner to the point where it's received by an appropriate recipient. So we add sort of this piece, like kind of like HTTPS for dApps or for blockchain applications at NuCypher. So we're basically giving developers and other dApps a way to securely manage and share private data. So it could be anything from names, addresses, social security numbers, health records, any kind of sensitive data, and giving
Right.
people a way to deal with that in their DApp. And then the way we've done that is using this technology called proxy re-encryption.
Yeah,
And
that was
proxy
my
re-encryption is just fundamentally.
yeah, that was my next question, by the way. So, what do you? I mean, what is this, right? It's kind of a new it's kind of a new encryption keys or decryption keys, let's say. Yeah, definitely in some of the areas, in some of the businesses or geographies or countries, apparently this could be a question mark. And peer-to-peer is understandable, but then how do you do it on a mass scale? So is that what you, I mean, is that the term that you're using for this, let's say, for this approach?
Yeah, so the core technology that's powering basically the system that we've built, the protocol that we built, is a phone and a web server, or between you and I. So let's say I have some secret message that I want to share with you. I can use traditional public key encryption to encrypt that message with your public key, send it to you across the network, and once you've received it, you can just decrypt it with your private key, and it works very well.
Right.
But where it doesn't work so well is now, let's say I need to share that message not just with you, but with a dozen, 100, 1,000 recipients.
Exactly.
I need to encrypt that message a dozen, 100, 1,000 times, send it across the network a dozen, 100, 1,000 times. It scales very poorly. Whereas with proxy re-encryption, what I can do is encrypt the data one time under my own and delegate and revoke access to that data to as many recipients as I like. And then when you combine that with things like smart contracts and blockchain, you get this interesting thing where you can do conditional sharing. So you can have access controls on top of your data in a DApp, like an IPFS or Swarm, and only conditionally grant access to people. So for example, you only want someone to have access to your data if they pay like 5 ETH to your address, for example, or within some certain time bound, or conditional on some event. And that's kind of another interesting aspect to NuCypher.
Right. And I mean, the tricky question, of course, is, I mean, we don't want to disclose any like sensitive information, of course, but the key question here is things, of course.
Sure. So proxy re-encryption itself is not something that we invented. It's been around primarily in academia since I think the first paper was written in 1998.
Oh,
I'm
wow.
the first company that, at least that I'm aware of, to meaningfully productize or commercialize it. So we did a lot of work there in terms of making it, robust enough for production use, so taking care of things like side channel attacks and other re-encryption. The way that it works is I've encrypted some data, I've stored it. I can then give that re-encryption key to a proxy that can use it to rekey the data so that you can then decrypt it. And traditionally, there's one proxy, there's one re-encryption key. What we've done for NuCypher is we've created a split key threshold version of proxy re-encryption. And so what that means is instead of one re-encryption key, we take that re-encryption key, we chop it up into a bunch of shares, and then we distribute those shares to nodes in the NuCypher network. So we're basically splitting the trust across many different nodes. So if a few of them become malicious or go offline or misbehave for some reason, the system will still work. It's fine. And that's something we've added, and that threshold is configurable. So as long, you could say like you can require 2 of 3 shares or 10 of 20 or 30 of 50, whatever you like of those shares to come together in order to do the re-encryption. So this adds a lot of redundancy to the network. It adds this sort of censorship resistance aspect. It makes it a lot harder for node proxies to collude, for example, with a recipient.
Right. Wow. Very interesting. Also read in your white paper is the fact that you for some reason you're focusing a lot on the big data. Is that like some?
Typically, where you see proxy re-encryption have a lot of value beyond traditional public encryption is any scenario where you need to share data across multiple recipients. And in practice, that tends to be what a lot of these distributed systems look like. So big data platforms like Hadoop and Kafka, where you're computing on data across a bunch of Hadoop nodes, or Kafka, where you're streaming data to many different data consumers, or obviously in the blockchain space where it's totally decentralized. Potentially some stuff in like IoT, where you've got many different sensors that need to stream data or consume data. So really, like where proxy encryption has a lot of value is systems that are characterized by this multi-party recipient or data sharing pattern. Big data is one of those. Blockchain is another, and I think our primary focus is blockchain, but big data is just another sort of valid application of proxy re-encryption.
Yeah, it does make sense, of course. Listen, just another maybe sensitive question, if you don't mind. I don't know if you're familiar with them or not. From what I heard, they started earlier than a little bit than NuCypher. They also, I mean, they have quite a strong team apparently, but just we don't follow what happens with them. But I mean, how do you see the area in terms of the players, friends or foes or whatever you call them?
Yeah, so I'm not familiar with Avanon specifically, but I'll look at them after the call. So it depends on how you look at the space. So if you look at just this data protection space very broadly, traditional centralized solutions like data masking companies like Protegrity or HP Voltage could be considered competitive, or any of the key managed services like AWS Cloud HSM or Azure Key Vault or HashiCorp Vault could potentially serve similar use cases. And then if you look at blockchain space specifically, it's much sort of a more nascent space. There's not a huge number of projects working on the data privacy piece right now. The closest kind of comparables would probably be the companies that are working on MPC or multi-party computation technology, which can be used potentially for similar sort of data sharing use cases. And then also projects that are looking at TEE or trusted execution environments, which is more of a hardware-based solution, where you have things like Intel SGX and like a secure enclave where
create and decentralize, let's say, encryption and decryption. Which use cases do you envision as the most natural for this type of task? I mean, okay, data storage maybe is one of them. Messaging, apparently. Like, what else? What do you see as the other things?
Yeah. So I mean, I think fundamentally, NuCypher is meant to be horizontal infrastructure for access control. So anyone that's managing private data and needs to share it. The very obvious kind of low-hanging fruit use cases are the ones you mentioned. Like you could create a decentralized Dropbox that's end-to-end encrypted, for example.
Right.
So you're sharing encrypted files. A very nice use case for proxy re-encryption is end-to-end encrypted group chats. So like end-to-end encrypted group chat actually is a difficult problem, even in a centralized context. So setting aside blockchain for a moment, it's hard to do. Like if you take Telegram, for example, all of their group chats are not encrypted; they're in plain text, and this is because it's very expensive to encrypt all the participants in a group chat. And with proxy encryption, you can do that actually fairly easily. So that's a very good use case. I think there's a lot of interesting stuff happening with IoT and in terms of some of the projects that are starting to use NuCypher, like how you secure data that's being streamed back and forth between a lot of different devices. A lot of the early traction we've gotten has been in the healthcare space. So there are many different projects that are trying to create patient-controlled medical record systems. So like MediBlock in Korea, for example, or Wholesome.io or Irio or HealthCombics. There are a bunch of projects that are using NuCypher as this access control piece to share medical records with healthcare providers or doctors. We are also the access control layer for a lot of the newer decentralized databases that are coming out, like BlueZell, Wolk, and Fluence. I think recently we had an interesting partnership or use case with Origin Protocol, which is the sharing economy protocol. They're trying to build kind of the infrastructure for people to build decentralized Airbnbs or decentralized Ubers, and they can use NuCypher to, for example, reveal the address of a house once a booking has been made, but hide it and keep it secret before that. So there's a lot of, I think, interesting use cases that are starting to pop up.
Oh, cool. That's a you just just said about the Origin guys, because they, I mean, you probably know that we also, as a fund, we also support them a lot, as much as you as well. So it's great that there is some some marriage with strong projects like yourselves, in doing things together. Yeah. All right, but just about teams, by the way, since we touched on this thing, For those who are probably looking in this area, there's always this very vague idea in terms of how big should be the team who is actually building this. Because I mean, if you look at some of the projects in the blockchain area, like the famous EOS or so the Hashgraph guys and whoever else, right? Them raising like the exorbitant amount of money, of course. It looks like they're after hiring like a whole town of programmers who would of coders who would be doing, I don't know, like really very high tech and difficult tasks. With you, it looks like you're more of a commando type of team, really tight, really shrewd, down to the point. And is that the feeling that I mean, is the feeling that that we have, exactly what you guys are having? I mean, in terms of approach to the team, how big is it? Are you hiring anybody, and so on?
Sure. So I think we are 11 people right now. Still, the bulk of those are on the engineering side. So either engineers or cryptographers, security people. We've got sort of community lead who's helping kind of grow our community and engage with developers. Recently hired. Talk about hiring a ton of engineers in general. Like the pace of development is so much of the work. So there's a famous book about software development called I think it's the Mythical Man Month. It talks about this. So you can hire 100 engineers, but that's not necessarily going to make the development go any faster. And in fact, at a certain point, it's almost certainly going to slow things down. So we've, I think, very consciously kept the team relatively small. We've hired people that we only feel very strongly can add a huge amount of value. So all of our engineers are one, I think, complement each other very well and work well together as a team, but are also very strong and talented individual contributors. We are on the actively hiring front. We are looking for someone to. So that's something that we're looking for actively right now, but probably not looking to hire a huge number of people between now and the network launch, just because I think we have a very clear path towards that, and it's difficult to kind of onboard too many people while we're so busy with that. But after protocol launch, we'll probably look to hire a few more people to maintain and support and actively work on the protocol.
Right. Cool. I mean, it's probably also like a tiny announcement of the thing that we're going to launch this weekend. I mean, as you definitely well know, there's going to be a small hackathon that we're running in Moscow, as part of the as a blockchain summit over there. And you're basically one of the largest participants over there in terms of the tasks that you deployed there for the teams to actually work on. Any expectations in terms of like what exactly do you expect from the guys that are planning? I mean, that are going to be working there. What's your idea?
Apologies for moving my alarm. It really goes off.
Oops. Well, it's actually usually
a lot of technology happening.
Yeah, it's usually very good for like motion picture, the two boring talking heads. So that's quite good.
Yeah, that's out of the way. On the hackathon side, we're definitely looking. NuCypher is fundamentally a developer tool. So one of our priorities, obviously, is engaging with the DApp and the developer community, doing a lot of developer evangelism, a lot of developer marketing, basically increase developer awareness about NuCypher, so that when someone starts a new project, we can just out of the box more or less solve the data privacy problem for them. So that means in practice that we sponsor a lot of hackathons. We love to engage with developers there. We're very interested in speaking at like dev meetups, technical meetups, conferences, things like that. And so we're definitely looking forward to the hackathon with you guys this weekend, and hopefully more in Russia and Moscow in the future. Particularly excited about it because Michael, my co-founder and our CTO, is originally from originally from Russia. We have one engineer still in Moscow right now. So we definitely understand that like the Russian community is extremely strong, and we would love to start working with more projects from that area.
Thanks very much. That's a good sign to hear. I mean, listen, just probably the last question here. In blockchain, a number of projects that are building something, they're all about changing the world in the future, right? Making some bigger impact. So what's your big picture on the whole thing? Like, how do you plan to change the world for the better? If that's the case, of course.
Sure. So I think the way that we look at it is, for the blockchain space in general, it's still very early. There's structure that needs to get built. Specifically things like scaling or performance, off-chain computation. Obviously, the infrastructure piece that we're focused on is the data privacy aspect. So we really just want to solve that infrastructure piece so that the developers that are building these very kind of futuristic or next generation Web3 dApps are able to build on top of us and leverage the low level infrastructure built to build these more kind of futuristic dApps. And I think a lot of the motivation for, or a lot of what's driving the interest about blockchains and decentralized applications in general is this idea of giving people greater control over their data, specifically how it's being used, who has access to it, how it's being monetized. In many ways, just kind of as a pushback against a lot of the large centralized technology incumbents. And I think that's not, NuCypher fits, I think, very well kind of into that theme. We give people a way to have control over that data and have it be private and shareable. So I think we're just very much interested in the technology stack for this decentralized web, and helping as many of these dApps launch and be successful as possible. Right.
Okay. Well, I guess we'll probably be rounding up. And you know what? Maybe a personal question here, if you don't mind. Let's like 10 years from now, everything that you've have that have everything realized.
And I think this is true of really every time there's a significant sort of change in the technology paradigm, or there's a new computing environment. So if you think back to when smartphones first came out, it very much looked like people would just try to take a PC application, put it to a smartphone. It took a while for kind of the technology to incubate and people to understand that this new by having a smartphone pocket, you open up like this entirely new set of applications, like an Uber, for example. You're on the street corner, you pull out your phone, you call a taxi to come pick you up, which didn't make any sense, obviously, if you just had your PC at your home or your office. And I think there's a similar thing happening with blockchain and crypto, in that right now, the vast majority of applications that are being built are just web apps or mobile apps that are being ported to blockchain, and people are just putting a payment token on top and saying it's a dApp. And that's, maybe some of those will be successful, but in general, that's not particularly interesting. I think there's likely going to be a bunch of newer native applications to blockchain that just weren't possible or didn't make any sense prior to blockchain. And I think we've seen a little bit of that, like some early indications of that with things like non-fungible tokens or digital collectibles. So the most high profile use case being like CryptoKitties, which is like kind of now, but I think potentially could turn into something really interesting. And then hopefully there'll be many more of those types of things that we discover kind of as an industry or as a community. I think the theme of that, I don't know like what the specific application will be yet, but I think the theme in general kind of tie back to what I talked about before, which will be just giving people greater control over how they interact with the web, how they interact with other services, greater control over their data, who has access to it, who's able to monetize it. There's kind of greater kind of more basically auditing of like how that data, exactly how the data is being used, which in many ways I think was kind of going back to the original inspiration for just the traditional internet. You know, people, when it first started, it was very idealistic. It was a bunch of cypherpunks that like were creating this sort of open, you know, network where you could engage with anyone in the world, kind of peer to peer, and you know, then it kind of over time became this very heavily centralized thing. And so I think in many ways, kind of people are optimistic that potentially blockchain and tokens will kind of allow us to rebuild the original vision for what the web was, you know, back before it fully centralized and became dominated by, you know, 5 or 6 large internet companies.
Right, right. Well, let's wait and see what the future will bring to us, man. I mean, it's really exciting times, and thanks for your time, and thanks for, you know, making such a very interesting and very deep, in my, you know, opinion, you know, deep effect on the industry itself. And we'll definitely somehow cooperate with part of your team this weekend, and hopefully, you know, see and hear from you in the near future.
Awesome.
Thanks very much.
Thanks so much, Alan. Great talking to you.
Yeah, great. Cheers.
Cheers.
Have a good time. Bye-bye.